Alright guys, now we're going to be talking about the filter portion of Retro Synth. Okay, now this filter is going to exist across all the different oscillators, so at this point we're starting to learn about the whole plugin, not just the analog portion. Up to this point, the filter has actually been turned off, so if you go up here to the power button and actually click it on, we're going to start to notice its effects. But first let's talk about what a filter is and the different kinds of filters that Retro Synth lets us use. Alright, think about filters like an EQ. Okay, that's all it is. It's either boosting or rejecting certain frequencies. Now if we go to this drop-down menu, you can see we have lots of different types of filters. There are actually only 5 types here, even though there are different versions of each type. Okay, we have this LP, that stands for low pass, and that means exactly what it says. It's going to allow low frequencies to pass while it cuts high frequencies. We have band pass filters. This allows a certain range of frequencies to pass as it cuts highs and lows. High pass filters would allow high frequencies to pass as it cuts low frequencies. Down here at the bottom we have a band reject filter, that's the BR, and that just means we're going to be cutting a certain band of frequencies, but we're not going to be cutting the highs and lows, okay, just that certain band. And then we have a peak filter, and that means we're going to be boosting a certain range of frequencies and not cutting anything else. You might be wondering what the 6 dB, 12 dB, 24 dB stands for next to these. That is just the steepness of the cut involved. Okay, so if we have a 6 dB low pass filter, it's going to be cutting into the highs, but at a relatively shallow rate. It's not going to be as steep of a cut. Whereas if you go up here to 24 decibels low pass, you're actually going to really deeply cut into the high frequencies, so it's going to start cutting into them a lot sooner. Since I kind of want this harmony to sit in the lower registers of my mix, I'm going to use a low pass filter. Okay, I don't want it to be too bright because I don't want it to distract from some of the higher frequency instruments. But you could do the opposite if you want something to really stand out and kind of take space in the higher registers. You might want a high pass filter. Or you can have it really cut through the mid to high mid range using a band pass filter. Okay, then it's going to kind of take space up between like 1,000, 2,000 hertz. We're going to use this 24 dB low pass filter. Okay, now you see this little graph here is what you're going to be working with first. Okay, it's got a few different components to it. Okay, imagine this is your EQ distribution. Okay, just like you would see that flat EQ line if you opened up channel EQ or something like it. We also have this dot at the end of our flat response. Okay, now this dot is called the cutoff point, and it's from a value of 0 to 1. And you'll notice that as I drag it along the EQ distribution, we actually have a line that follows it that cuts into the high frequencies. So as I drag this down, I'm actually reducing the amount of high frequency contained in this synth sound. Alright, so I want this to be relatively dark. I don't want it to contain a lot of high frequencies, so I'm going to play the harmony and kind of find the sweet spot that I want to the point where I can still hear it. Okay, it's still going to be heard in the mix, but it's not going to distract from the other high-end elements. Alright, so something else you may want to consider when you're setting this cutoff point is another parameter directly associated with it called resonance. And the resonance value here is also from 0 to 1. It's actually going to add a notch at your cutoff point. So you notice that I'm actually boosting the frequency of my cutoff point as I raise this value. So you might want to experiment not only dragging your cutoff from left to right, but also noticing what frequency is impacted by that resonance value, because that's going to have a lot to do with where your synth sits in the mix. Okay, what frequency is it really occupying? So with this pad that we're creating with this harmony line, we don't really want a ton of resonance, because at that point it would be cutting through and it's not sitting in the background like we were wanting it to. But a little bit of resonance to have it, sit snugly, basically. Not be an afterthought or just completely forgotten back there. Still want to hear it as a separate element, but I don't want it to distract from other important parts of the mix. Now this key slider on the right is actually going to help us emulate something that we notice with real instruments. In real life, when we play higher note values, they actually sound brighter in tone than the low notes. If we have this set to the top of the slider, we're actually not going to cut into the highs as much with the higher notes. Okay, so they're still going to be brighter than the lower notes. Whereas if we pull this down to the bottom, the high notes are just going to have the same cut into the high frequencies as the lower notes, and inevitably that's actually going to make the lower notes seem brighter, because that would be kind of unnatural for it to work that way.